Hello my dear students, welcome to lecture number 8 of chapter 5. So from this lecture we have started our journey in proving the theorems, and this process continues till class 10. In this lecture we will have been encountered with a theorem and we will learn how to solve and how to prove that theorem using a given procedure by the help of axiom, postulates as well as definition. So without wasting the time, let's start the first theorem. Okay, so here the first theorem is prove that two distinct lines cannot have more than one point in common. So let us understand this statement clearly. It is given that there are two distinct lines. So let us draw two distinct lines, L1 and another line, L2. Then you have to prove that these two lines will meet each other at a single point, or these two lines cannot have more than one point in common. Right? Focus on the word two distinct lines. What is the meaning of distinct lines? Two lines are said to be distinct if the two lines are not coincided with each other, if the two lines are not superimposed with each other. Let me tell you an example. Suppose there are two lines, line L1 and another line L2. Then these two lines are said to be superimposed with each other when you trace the copy of a line L1 over the line L2, so that the line L1 completely and exactly cover the line L2. Then these two lines are said to be superimposed. Okay, that means you draw the copy of this line L1 on L2 so that the line L1 completely and exactly cover the line L2. Right? Now, suppose I take a point P1 on the line L1. Then you could see this point is also a point on the line L2. Right? So what you find? You find that the point P1 is common to both L1 and L2 line. Similarly, if you take another point P2 on the line L1, then you could see that that point is also a point on the line L2. So P2 is also a point on L2. It means P2 is a point which is common to both L1 and L2. Similarly, if you take another point P3 on L1, then this point is also a point on L2. So P3 is also a common point to both L1 and L2. It means if the two lines are coincided with each other, then each point on that line are common to both the points or both the lines. Okay, so there are infinite number of common points among or in between two coincided lines. So you can note it. There exist infinite number of common point among two coincident line. Understood? So in case of coincident line, you get more than one number of point in common. But here the statement asks for distinct lines. So how could you draw distinct lines? Distinct lines can be drawn by two cases. What are the two cases? The first case is either the two lines are parallel, then these two lines are distinct lines, or the two lines are intersecting lines. These are the two conditions or two cases in order to draw two distinct lines. See, if the two lines are parallel, then according to the definition of parallel lines, you know the two parallel lines never meet each other if we produce them in any other direction, right? Since the two lines do not meet each other, that means they do not have a single common point. So it is proved for parallel lines. So our next target is to prove for intersecting lines. So let's start proving the theorem. Okay? And now I will tell you how to prove a theorem. Right? So from the statement, it is given that there are two distinct lines. So write it first. Given there are two distinct lines L1 and L2. But I don't know whether the two lines are parallel or intersecting. We only know that there are two distinct lines L1 and L2. Then what we have to prove? We have to prove that the two lines cannot have more than one point in common. So to prove two lines L1 and L2 cannot have more than one point in common, right? Then let's prove it. So proof. As I have told you, the two distinct lines L1 and L2 may be parallel or they may be intersecting. So there are two cases. So the first case is two lines are parallel. So first we have to solve for the two parallel lines. According to the definition of parallel lines, we know that two parallel lines never meet each other. Okay, so write it. According to the definition of parallel lines, that the two lines never meet each other. Two lines never meet each other. So if the two lines never meet each other, it means they do not have a single point in common. Okay, it means they do not have more than one point in common, right? So you can write, so they don't have a single point in common. Okay, if you produce these two parallel lines in other direction, then you could find that they never meet each other. Why? Because the distance between these two lines is always remain fixed. So why they will meet each other? They will not meet each other. Okay, so case 1 is proved. Next we have to prove for case 2. What is the case 2? The case 2 is if the two lines are intersecting lines. Okay, so write it. If the two lines are intersecting. Okay, in order to prove this case, we have to use a special method that is known as contradiction method. What is a contradiction method? In contradiction method, we have to assume or we have to suppose a false statement, and then at last we have to prove that the assumption that we have taken is wrong. Understood? So first we have to take a false statement. Okay, as we have to prove that the two lines cannot have more than one point in common, but we have to assume, we have to consider that the two lines L1 and L2 have more than one point in common, or they have 2 points in common. We have to only assume it. Okay, so let's assume. Let us assume L1 and L2 line, okay, have 2 points in common. See, as we know, yes, two intersecting lines will pass or will meet each other only at a single point. But here we have to consider a false statement. What is the false statement? The statement is that these two lines L1 and L2 have 2 points in common. Okay, what are the 2 points? P and Q. Okay, so these 2 points are common to the line L1 and L2. Since they pass through two distinct points, that means these 2 points are distinct. Yes or no? Yes. Hence, the 2 points P and Q are distinct. Hence, the points P and Q are distinct. Why they are distinct? Because these two distinct lines pass or meet each other at two different points. What are the different points? P and Q. Different point means these 2 points are distinct. They are not considered. Okay, suppose there is a point P, then in another position there is a point Q. P and Q never meet or never coincide each other. Understood? So P and Q are the two distinct points. Now remind the axiom number 5.1. Okay, in axiom number 5.1 we have studied that in between two distinct points there is one and only one straight line. We have studied in postulate 1, axiom 5.1, that in between two distinct points there exists one and only one straight line. Understood? So write it, but suppose I am writing it in this portion. Okay? But in axiom 5.1 we have studied that in between two distinct points there is one and only one straight line. Only one straight line can pass. Okay, so through these 2 points you can draw only one straight line, not more than one straight line. But as you have taken that through these 2 points, through these two distinct points P and Q, there are two lines L1 and L2. But in the exam it is given that through the two distinct points you can draw only one straight line. It means your assumptions that you have taken that L1 and L2 are two distinct lines and they meet each other at two distinct points, which is wrong. Understood? So you can write, so our assumption is wrong, which contradicts the axiom 5.1. Why it contradicts the axiom 5.1? According to the axiom 5.1, it is given that through two distinct points we can draw only one straight line. But here it is given that through the 2 points P and Q we have two straight lines L1 and L2. It is completely wrong statement. So this statement contradicts our axiom number 5.1. Okay, hence our assumptions that we have considered is wrong. Hence our assumptions that we have considered is wrong. So what do we get? So we get that the two lines have only 1 point in common, not more than 1 point. Okay, so we get the two lines L1 and L2 have only 1 point in common. They don't have more than 1 point in common. They have only 1 point through which they can pass. Now understand it. This is the contradictory method. In this method you have to first assume a false statement. Here we assume that the two lines L1 and L2 have two distinct point of intersections like P and Q. So P and Q are the two distinct points. Okay. But according to the axiom, you know, through the two distinct points you can draw only one straight line. But here you have two straight lines. So your assumption is completely wrong, and your assumption contradicts our axiom. So our assumption is wrong. So what we get? We get that the two lines L1 and L2 can pass through only a single point. So they have only one point in common, and they don't have 2 points, or they don't have more than 1 point in common. This is our proof. Hence it is proved. Right?